So still they are under test beds. And today it happened that Amaravati Quantum Valley at this same time 4 p.m. The CM of Andhra Pradesh is laying the foundation stone for Amaravati Quantum Valley. So this is going to be the first quantum ecosystem is being established in entire India. So this will be projected as like a Silicon Valley in USA, and this will do brain gain, not brain gain, brain. So till yesterday it was brain drain from India to other countries wherever opportunities are there, people were flowing. But now people will come to this quantum valley, to this holy land, Andhra Pradesh, and they will nurture their skills and excellence.
colleagues, here the data set is taken from the public crop regulation data set from the project, but the main disadvantage of this particular data set is that it is available in the Telugu, but the same data set here we converted into the English, which will consist of 5,200 records with the different crops classifications on the 22, and we have the data input features like soil, soil fertility, pH value, temperature, humidity, and rainfall, and the data set split itself is divided into two parts, 80% of the training set and 20% for the testing set. These are the various results compared to the different algorithms without quantum and with quantum, and also we go for the higher hybrid fusion method with postulated algorithms. In some of the cases, the quantum exposes the better accuracy. In some of the cases, the quantum is not suitable because it will take more time for execution of the particular one. So these are some of the results related to the classical algorithms that we Stanford College related to issues. There in these fibers we stand and ensemble methods. Here we are choosing a different classical algorithms also. So this is another result related to the Telugu with an intent accuracy and F1 score and language understand and the training time. So I already mentioned in some situations this particular classic quantum QPT is lagging in respect to the time. And final conclusion, and obviously we don't have a particular hardware approach for this particular quantum. Here we include the quantum related to the optimization only. And this particular one is very much suitable for the Telugu language. And come to the future one, we can extend this particular one related to the other Indian languages of the regional languages. And the main important thing, with the help of any quantum algorithm, if it is available within hardware, that leads to the better accuracy. So these are the various differences which we are using this particular one. Thank you.
So, myself Lakshma, I am from Race College of Engineering, Toothpick, Tamil Nadu.
Oh, great.
My research area is quantum machine learning in cybersecurity. I am currently pursuing my PhD from SRM University, Tiruchirappalli campus. And this is my main area of research. So, when I started with quantum machine learning, what issue I faced is full quantum is not possible right at the moment because of restriction in qubits and other things. So I started with full quantum, but because of the novelties, most of my papers got rejected, and one of the conference I posted is they are saying that it's still in novel stage, we can't able to approve like that. So then I think into that, what's the next better option? So what's the next better option is we choose combination of both classical and current quantum. So how we can do it? What is best for what? Okay. So here we merge two parts. One is classical quantum for the pre-processing stage and quantum for the insider thread detection. Basically, what is insider thread is we have a lot of company people who are there in our company, and they are using the company's data for some illegal purpose. They are downloading it and sharing with their company other organization, and they are leaking our products and everything. So those things are called as insider threats. So how we are going to find those things? You see. So this is the difference between insider threat and other threat. Insider threat is not just brute force or password hacking, those kind of threats. Insider threats is they are downloading our database, or they are leaking our emails, they are taking the client details, those kind of client details, and they are taking up unauthorized time, or they are keep on getting those kind of details related to buildings and sharing with the other organization. They have the access, they are misusing their access. That's the insider threat they are doing. So what's the issue right now is, if you see for this data set, we took certain data set is having 4.3 million logs. So just consider that's a big haystack. What we need to find the inside the thread from the big haystack? It's like finding a needle in the haystack. That's the issue we are facing with the existing thing. So what we proposed is, for using classical, we reduce this data into a readable data to the quantum, then process the quantum data to find the inside the thread. That's the proposed idea we proposed here. So here, why traditional AI struggles here? Why traditional AI struggles? Because of, I already told that traditional AI struggles because of they are saying concept of dimensionality. It's not like that. So because of large data, we can't able to pinpoint what we are trying to infer from that. That's the main thing we are struggling from the large data. That's why we are going for a different approach than the existing approach, that is quantum machine learning approach here. So what's the power of quantum here? Why quantum is coming into consideration is, it is able to find the correlation between the user and the data what they are accessing. I already told that inside the thread is nothing but user is leaking some data, user is accessing some data with the intention of leaking. In the intention of leaking means what we do. I am a user, I am an insider, I want to leak the data. So what I do is, I will log in into the time of 2 AM, then I will download the entire data set. So I will have a connection between this much to this much, and then I will log off very quickly. So this kind of correlation will take, this kind of correlation can be able to process by quantum very easily as compared to the existing models. That's why we are going for quantum to process this kind of correlation. How we are processing this kind of correlation is using quantum entanglement. Quantum entanglement will create a linear cycle between user and their behavior. So when the user is changing or downloading some data, the quantum entanglement thread will get stronger. So we can able to find out whether he is using that authorization for wrong purpose or right purpose. We can able to predict. That's why we are going for quantum in this part. Okay. So here is the two parts. I already told we are using two parts. One is for classical one, another is for quantum processing. Classical is nothing but to minimize or compress the existing data into chunks using tensor networks. After that chunk is very small, we can able to give that small inference to the quantum processing. Then we can able to find the inside the thread information using quantum processing. So how we are going to convert this small large data into small is using tensor networks. How tensor network is able to minimize the large data into small? It's like origami. Origami, how it will work is, if we have a large paper, we draw dots on that paper, then we'll minimize this paper into a small paper. Then if we stretch that paper, the paper will be written to its whole stage. Okay. So how it is performing using Tucker decomposition. Using that, we can able to minimize the data around 90%. Similar to image compression. Image compression, what we usually do is, we will have only needed feature. With the needed feature, we can able to have the same quality as the original image, and we will reduce the unwanted image, like unwanted features. Like just take as a photo example, 3 MB photo is there, and we can able to reduce to 300 MB without losing any feature of the original data. The same here also is applicable. So here we have a original tensor. That tensor is minimized into coarse tensor. Whatever I am explaining, we'll see in the code itself, so that we'll have a clear understanding in the later part. I have a collab and I can able to show that part also. So how we can able to achieve above 90% compression rate. Okay, so it's currently I have around 99% compression rate for our tensor. Okay, so this till that part is like classical quantum. Now we able to we have a massive amount of logs. We are minimizing logs to the processing state for the quantum. Then after that, quantum run begins. Quantum run, what we are doing is with 8-bit qubits, we are so this is the part. I already told that how quantum entanglement works here. So user is inside the user is accessing file at 2 AM. So this entanglement process will check this is a normal behavior or abnormal behavior using quantum mutual information. So quantum mutual information will have a score. So if he is accessing at the abnormal time and he is having using more than 2 devices, like this, it will increase the quantum mutual information score. If he is having more than 75% quantum mutual information score, it will be detected as a insider. He is leaking organization's data. Like this, it will detect. So like this. So if the quantum mutual information score is high, only it will be detected as an anomaly. Otherwise, it will be detected as a routine behavior. So these are the things we compare with the existing one. So existing classical classical machine learning model, we achieved around 76% accuracy, and using only tensor encoder, we are achieved around 80% accuracy, and with our model, we are achieved around 91% accuracy with search inside a data set. So this is the difference how it is segregating anomalies and normal interactions. So normal interactions are in the center part, anomalous interaction are showing in the outer dimension parts. So this is the difference between why we need both quantum and classical. So classical we can able to achieve only 83%. With quantum estimator we can able to achieve around 90%, 91%. That's why I always suggest with quantum, with classical we can able to increase the right time. We can able to increase our existing systems accuracy and predictability. Okay. So another thing, we created a full model. Right now, within 50 milliseconds, it is able to detect a new insider. So now I have created a model. Now new people is trying to log into the system and downloading the files. It is able to real time. It is able to detect in 50 milliseconds. So without losing any data, we can able to inform these people's leaking the company's information. So shut down his system or flag incident like this, we can able to do. And another thing, I already told that compression ratio. I compress the ratio of 2.3 million logs to 96%. So because of this one, that entire quantum execution is much faster as compared to the existing one. Okay. So this can be used beyond cybersecurity. I already told using behaviors and using log patterns and those kind of data only we are predicting the insider information. So if we have IoT sensor, we have an entire building or entire factory with the malfunction sensor or something like that. That can also be, we can able to predict that one, and patient's vital information, those kind of data also we can able to predict. So this we can, I can show you in a few moments. Okay. So this is practical now itself, because in future if quantum comes, we don't have to wait for this one, because we are combining both quantum with the existing system. So now itself we can able to implement this one. We are not telling this as a theory. So this is a practical implementation we have done. We have achieved all the necessary validation also. Let me show the code for the understanding. So this is the since we are not able to run the entire set, I have to around 1 lakh events with logon, file, email, HTTP and device. So logon means which time is logging on, which file is accessing, his email and HTTP, and how many devices he is connected inside the person who is logged on currently. Okay. So this is the first step. here I am making user 7 as an insider to showcase my results. User 7 as an insider. So with the he is accessing the file for 30 in a day. So he is accessing with the abnormal pattern as compared to the regular pattern. So this is the existing thing, user behavior and day. Current day, which user and which kind of behavior is accessing the system, those kind of details we do, and we are creating tensor with this element. The current tensor size is 15,000 before compressing. After compressing, if you see, we are using TensorFlow decomposition. It is used to compress the current tensor. After compressing, its only compressed size is only 150. So we have achieved 90% compression. So we have converted the data from 15 KB or 15 GB to 1 GB. So 90% we compress the data to feed into the quantum state. And next thing is the quantum part. Till now is the classical part. Quantum part is, and difference between quantum and classical approach is we can't directly feed the text or back to the quantum. We need to give us a quantum matrix like rotation. So that's why we are including quantum futures here. After creating quantum futures, we are creating, as I already told, we are using 8-bit quantum to create the quantum diagram. Here we can see number of bits we have given. I hardly go into the prediction part. So here this is a normal user. So if this user is user 62. The 62 user is having quantum QMA of 0.16. It's 16%. I already told I have made only user 7 as an insider. If I give user 7, I can able to achieve around 70% more quantum mutual information. Here in Colab itself, I can able to achieve 150 millisecond accuracy. Within 150 millisecond, it is able to predict that the current user is an insider or not. So with this, we can able to find out any insider threats from the real time, using real time, without depending on the existing one. Once the model is trained and we have given the model to the system, it can be able to find the insider threat within 150 millisecond using Colab. If we have a higher system, we can able to predict that attack in 50 milliseconds. So this is entirely related to my code. So I just want to I prepared an AA video for this my presentation using
No, we don't have time.
in Telugu for
No, we don't have.
We will take care of it. We'll come on optical. I will submit our optical engineer. We will come on.
Sounds like you did a good job. Now, only my question is, both quantum and classical approaches you are using, kind of, suppose you did the whole thing with classical. Suppose you did the whole thing with quantum. I think you mentioned doing that with totally classical. But if I remember correctly, you haven't done it totally in the quantum domain.
Yeah, so because of the restriction in the qubits, we can't able to entirely, I can able to simulate the results and I can able to give, but maybe in the future we can able to entirely implement this in the quantum.
Okay. Yeah. Any other questions?
So what is the data set you have considered?
Data set. It's Kahneman data set for insect reduction.
Okay.
Yeah.